video, let us see lens maker's formula and lens equation. So in one of my videos, I have explained refraction at a single spherical surface. So this is a equation for a refraction at a single surface. N2 by V minus N1 by U is equal to N2 minus N1. A spherical surface separating two media with the refractive index N1 and N2, and whose radius of curvature is R. Now here there is a lens. Now for a lens there are two spherical surfaces, then refractive index of the outer medium is N1 and inside it is N2. Now here there is an object. From light from the object is incident on the lens and it is undergoing refraction, and its image should have been formed here, but before that it is again undergoing the refraction at the second spherical surface, and the final image is formed at I. Now this is the first surface and this is the second surface. Now we have to apply this formula for these two surfaces. First let us apply the equation for this surface. So now for this medium N2, for this N1. So here N2, then for this it is V dash. So instead of V, now we have to write V dash minus N1 U. Now for this surface, this is the image. That's why instead of V, now V dash. Now N2 minus N1 by, for this first surface, radius of curvature is R. So instead of R, we have to write R1. So we apply the equation for the first surface. Now for the second surface. For the second surface, light is entering from N2 to N1. So now it will interchange. So in N2, N1. Now here for this it is N1 and N2. It interchanges because here light is entering from the medium with the refractive index N2 to N1. Then for this surface, this is acting as the object. So instead of U, we have to write V dash. Final image is formed here. So V. So for this V, because the image is here, so it is V, this distance. And for this surface, this is the object. So instead of U, V dash. Now add these two equations. When we add these two equations, you can see N2 by V dash, N2 by V dash plus minus. So this term will get cancelled. Now here you will get N1, you are adding these two equations. So N1 by V minus N1 by U is equal to, you are adding these two. So here it is N2 minus N1, but here it is N1 minus N2. So you interchange this. N2 minus N1, this also you make it N2 minus N1. So the sign will change. Now here also N2 minus N1, here also N2 minus N1 after interchanging. So you can take N2 minus N1 outside. Now here 1 by R1. Since you have interchanged, this plus will become minus. So here 1 by R1 minus 1 by R2. After that, you take this N1 to the other side. So you will get 1 by V minus 1 by U is equal to N2 minus N1 by N1 into 1 by R1 minus 1 by R2. So this is the expression we got. Suppose the object is at infinity. So for U, we can write infinity. Then image will be formed at the focus. So for V, we can write F in this expression. For V, you can write F, and U, you can substitute infinity. Now N2 divided by N1 minus N1 by N1 is 1. 1 by infinity, so you can write 0 for that. So 1 by f is equal to n2 by n1 minus 1 by r1 minus 1 by r2. Suppose the outer medium is air, so for n1 we can write 1 and n2 you substitute n. So from this you can write like this: 1 by f is equal to n minus 1, because for n2 you substitute n, for n1 1, then 1 by r1 minus 1 by r2. So this equation is known as Lens-Maker's formula. Using this formula, they can make a lens with a particular focal length. For that they can decide the radius of curvature required with a material of particular refractive index. That is why it's called a Lens-Maker's formula. Now if you compare these two equations, so you can write 1 by f is equal to 1 by v minus 1 by u, because the right hand sides are equal. So from comparing these two equations, we can write 1 by f is equal to 1 by v minus 1 by u. So this is known as Lens equation. 1 by f is equal to 1 by v minus 1 by u. Thank you for watching.